Okay, this is a cracker of a question. We want to prove that, so using complex numbers methods, deduce that cos 3 theta, right, equals that, and sine 3 theta equals. So the hint here is consider cis theta cubed. Now, why would we be considering that? Well, we know that cis theta cubed, if I apply de Moivre's theorem, then this becomes cis 3, right, theta. So that's going to give us, eventually when we expand that, that's then going to give us our cos 3 theta plus I sine 3 theta. Okay, so that then, as we said, allows us, we've got our cos 3 over here. But how are we going to get all of this stuff here? Well, that's when we look at, what if we actually expand it in the bracket first, and we say, well, we know that cis theta is cos theta plus I sine theta, and we're going to cube that, right, and expand. And then we're going to equate the real and the imaginary. All right, so that sounds a little bit far-fetched, but let's have a look. All right, so we agree with this statement that cis theta cubed is equal to cos theta plus I sine theta cubed. And from above, we can replace cis theta cubed using de Moivre's theorem with cis 3 theta. And then on the right-hand side, we're going to expand this. So that's when you have to remember our best mate, Pascal. Right? So remember Pascal. 1, 1, 1, 2, 1, 1, 3, 3, 1. So if I was to expand x plus y cubed, right, this becomes x cubed plus 3. Now the x cubed loses 1 power, becomes x squared, then we get y plus 3 again, right, because we're going 1, 3, 3, 1, so that's my 1 here, my 3, right. Now x squared becomes x, and the y, it has a power of 1 here, it goes up a power, so that becomes 2. And what comes next? The 1, so that becomes 1. Y, the x loses all power, so it's got nothing there, so x to the power of 0 is 1, and y gets a power. Okay, so if we use that, that means we get here it's 1 cos cubed theta plus 3 cos squared theta times I sine theta, right, plus 3, now only a cos theta, times I squared sine squared plus, I cubed sine cubed theta. Now we're going to tidy up. So we've got cos cubed theta. Can't do much with this one either, so that just stays as cos squared theta I sine theta. Now, this next term, I squared, we can say, well, that's minus 1, so it becomes minus 3 cos theta sine squared theta. And then the last term, I cubed, right? I cubed is I squared times I, and I squared is minus 1, so it becomes minus I. So we've got minus I sine cubed. Okay, so now what we want to do is it's time to equate the real parts with the imaginary parts. And you go, yep, well, what's that? Well, if we come back to, let's just have our, I think we feel blue, right? If we come back to our cos sine 3, what this actually is that is cos 3 theta plus I sine, as we said at the start, I sine 3 theta. So if we look at equating our real and our imaginary coefficients, okay, let's take our real. So what's our real on the left-hand side? Well, the real is the cos 3 theta, and on the right-hand side, that doesn't have an I with it. and that doesn't have an I with it. So that means it equals cos cubed theta minus 3 cos theta sine squared theta. Now, we're sort of getting close if we look at what we're trying to get to over here. We've got a cubed, which is great, but they've got a 4 cos cubed and we've only got 1, and they've only got cos theta here, not sine. So lucky for us, we can actually replace sine squared with, you should be able to know that one, right? What is it? Remember, we know we've got sine squared plus cos squared equals 1. So therefore, sine squared will be 1 minus cos squared theta. Now let's just expand, gather our like terms, and hopefully we're done. So minus 3 cos times 1 is minus 3 cos theta. Negative times a negative is a positive, so we get 3 cos cubed. And lo and behold, 1 cos cubed plus another 3 cos cubed is our 4 cos cubed minus 3 cos theta. Huzzah! Okay, and of course, all that's left for us to do now is to do the imaginary. So don't mock my fancy eye. Okay, now, on the left-hand side, the imaginary is sine, right? Sine 3 theta. You don't include the I because that's the bit that's telling you that that whole section is imaginary, okay? So now on the right-hand side, that's the imaginary part. So again, ignore the I. You just have 3 cos squared theta sine theta, okay? And minus, again, we're ignoring the I. That's just telling you that it is imaginary. And like we did with the last question, we'll just replace cos squared with 1 minus sine squared. Cubed. Okay, what do we get? So just be careful how I've written that, because I'm looking at it going, oh, 3 times 1, but don't forget you are in fact timesing it by the sine theta. So it's 3 sine theta, and then it's 3 times minus sine squared, but then times by sine as well. So it's minus 3 sine cubed minus another sine cubed theta. So we get what we were after. Huzzah! Our job here is done. Quite satisfying, I hope you agree.